Well, welcome to Chapter 8. We're going to start on page 264, and we're not covering the entire chapter, really just 264 to 269, and we're going to cover just kind of one main topic in this particular chapter. And the part we're going to talk about really deals with strategy and then cost estimation. And let me get to the part here with some strategy. And we'll talk first about the strategic role of cost estimation. You can see what's on the screen there, obviously. Um, really, this is described in your book towards the bottom of page 264. And they're talking about, they give an example of Carnegie. And back in the day, Carnegie was very good at estimating cost, and that was his total focus. And he believed if he knew how much it cost to build something, he could continuously undercut the competition and still make a desired profit. So he's very focused on cost. And so that's what part of this chapter is about, is estimating cost and coming up with relationships between cost objects and cost drivers. We've talked about some of those in the past. And then accurate cost estimates are used to facilitate strategic cost management by doing a couple of things. And cost estimates based on activity-based, volume-based, structural-based, and also executional cost drivers. Um, and basically we're trying to figure out what's causing a cost. Is it an activity, some kind of a volume happening? Structural, basically, is it kind of based on fixed costs that are already there in the past? And what's what causes these costs to happen? How do they behave? What are the patterns behind them? And understanding these will then help us to be able to deliver good estimates, good planning, and performance measurement of costs coming up in the future. There are some steps used in cost estimation. They are listed in the book on the top of page 265. There are 6 steps, and they go through them in a lot of detail. Be sure to read those. They summarize them on the top um, of page 265. They mention a few things you can do to estimate or predict future cost, I should say. And actually, that's 4 items. And it says to facilitate strategy and develop implementation. They talk about cost estimates are important for firms that are really basing their performance based on cost leadership. And obviously, if you're going to be a cost leader, understanding all of your costs and how they behave is absolutely critical and necessary. They also mention value chain analysis and understanding what costs add value to a product and what costs do not, and focusing on those costs that do add value, understanding them, and so on. And of course, if a cost does not add value, could it be trimmed or eliminated and we'd still have the same quality of our product or service? Also, they mention to facilitate target costing and pricing. Obviously, if we know that our customers will pay X dollars for a certain kind of product or service, we need to be able to cost accordingly to be able to achieve a desired markup and gross profit. And then the final thing they talk about when they talk about using cost estimation to predict future cost is determining how many units or how determining cost in business units, basically a business unit being like a division of a company, and then also how will financial performance, how will that play a role into compensation or promotion of people running a particular division of a company or a business unit of a company. So if somebody's particularly good at keeping costs low and they meet goals that have been set in front of them, cost estimates or future prediction of cost can be used to compensate somebody a certain way. So that's part of the strategy when it comes to predicting cost. Now, how we predict cost, then that's what this slide's talking about. And it says here that the steps in cost estimation are really mentioned on 266 and 267. Both those pages take up a lot of this information. Of course, defining the cost to be estimated seems fairly straightforward and simplistic, but it is that simple, is trying to figure out what is the total product cost to manufacture something or deliver a service. Be sure to include all costs that go into making something or providing a service. Next is determining the cost drivers. What causes costs to be incurred? And they give several examples right in the middle of page 266. You know, a cost could be fuel expenses for a delivery truck. The cost driver is how many miles are driven. Obviously, the more miles we drive, the more fuel cost there would be. Another example is heating expense for a building. Cost driver, the temperature outside the building, right? If it's particularly cold, heating costs will go up, and so on. So just determining what the costs that need to be estimated are, and understanding what causes those costs to happen, what causes them to fluctuate, and understanding that will help us make predictions. Step 3, collect consistent and accurate data. Okay, so consistent, using the same time periods consistently, using the same basis of measurement consistently, using good and accurate information. Okay, how reliable is the data that we're using? Is it been proven to be correct, and can it be substantiated, and so on? So questions like that. Step 4 is on the top of page 267, graph the data. And showing this data on a graph will help us visualize strange patterns or outliers, anything that kind of is outside the norm that we would normally expect to see. And then we will talk about selecting and employing a cost estimation method. And there's 2 methods that can be used. And we're going to really just focus on one of them, the high-low method. There's also a method called regression analysis. We'll just kind of understand it, but we're not going to really follow through and do examples of it. We're going to focus on cost estimation. And then step 6, the final step, assess the accuracy of the cost estimate. Kind of go through, reevaluate your numbers, make sure that what you came up with makes sense. Okay, they talk about a percentage error of accuracy also. That's more to do with the regression method, which again we're just going to discuss but not really follow through with examples. And so the high-low method is the one we're going to focus on in this chapter, and that's why we're only covering a few pages of the chapter. And the high-low method, they really give us an example starting on the bottom of page 267, and they give us an example there of Ben Garcia, who's a management accountant with a company, and he's trying to come up with some cost estimates of maintenance cost in a manufacturing plant. And they give us quite a bit of data and show us the high-low method using that data on 267, 268, and 269. The regression analysis, they talk about a linear and a nonlinear model, really is going to deal with a lot more statistics, data analysis, and then coming up with a percentage of accuracy or a percentage of how well we think these numbers will work. And so we're not going to go into that in this class. It's kind of above and beyond the scope of our class, but I just want you to be aware of regression analysis and just that it's out there and can be used. Obviously, because it is much more statistical, much more math-based, it can be done in Excel or some databases and so on, it's obviously going to be more accurate. The high-low method's easier, a little bit simpler to use, so obviously it's not going to be quite as accurate, but for our purposes it'll be just fine. And so the high-low method is simpler but less accurate, just like it says there. And this method can be chosen by a cost. The method to be chosen would depend on the level of accuracy that's needed, limitations that might be in front of us in terms of how much time we have to do this, how much effort's needed, and the cost of getting this analysis done. Obviously, if we're going to get into a deep regression analysis, it'll take much more time, much more effort, and the cost, of course, then would be more expensive. We'd be spending more people time and maybe even buying some software and doing more data collection, and that would just raise the cost of getting this done. So sometimes it's just a matter of cost benefit. Is a high-low method easier, simpler, quicker? Will that result just be enough for us to come up with our answer and be okay with it? So the cost estimation example, again, it's on 266, 68, and 69. And Bill Garcia, and they say Bill in the slide I see, and it's Ben Garcia in the book, so that's interesting. Bennett or Bill Garcia, who is a management accountant, wants to estimate future maintenance costs for a large manufacturing company. And they're showing us several months worth of cost data here. And they graphed it pretty simple, right? Just cost on the vertical bar of the graph, and time is the horizontal bar. Okay, so just plotted several months, about 7 months worth of data, and we can see that we've got some months that are high and some are lower than others, right? So 23,000, just under 23,000 to almost down to 22.5, and somewhere between 2,300 and 2,350 are the highs and lows that we have. And so based on this information, Garcia feels that maintenance costs for August, and so you can see we've got 7 months worth, January through July, and he's estimating that based on what he sees here, that it's pretty easy to assume that somewhere in August, cost will be between 22.5 and 23.5, because our low is 22.5 and our high is 23,175, so a broad stroke, a broad range would be somewhere in between the high and the low that he sees. And so he wants to estimate a little bit better what August will be. And so he's going to look at some relationships here. He's going to look at not just maintenance costs that were incurred for every month. This bottom row is what he's been showing us the previous couple of screens. Now we're adding how many operating hours there were each month, and we're going to see a correlation. Okay, and this will give him a little bit better understanding. So he feels that there's an economic relationship between maintenance cost and monthly operating hours, which is a cost driver. So it stands to reason the more hours we're operating, the more maintenance cost that there would be. And so he's going to then graph this with some new data. And so our maintenance cost is still our vertical bar, but our horizontal now is based on operating hours. And so you can see here that May was low and July was high, and then we have April over here. Okay, so you can kind of see he's got the months now don't correspond the way they did previously. He's just simply going and plotting each month in relation to cost and total operating hours, and basically saying that when there's lower operating hours, generally there's going to be less cost. So the high-low method then is using algebra to determine a unique estimation between the high point in the data and the low point in the data. It provides a unique cost line rather than a rough estimate, because previously he just kind of looked at every month and goes, okay, my high point was almost 23.5, my low point was 22.5. It's fairly safe to assume that August will be that range. But he wants a better data point than just a $1,000 range. He wants a better number to be able to predict maintenance cost for August. And so the high-low method's right here, and this formula is right on the top of page 269. Y is the value of the estimated cost. A is the fixed quantity that represents Y when X is 0. And then B is the slope of the line. X is the cost driver. Now it looks kind of complicated, but I promise you it's really not that bad. Okay, and all he's going to do is look at his graph and pick two data points. The one that represents the lower points, and one representative of the lower points and one representative of the higher points. Okay, it says they're often but not necessarily the highest and lowest points on the data set. Sometimes you can have maybe an unusually high month or an unusually low month. You might call an outlier and just say something was unique that month that caused that to happen. That's unusual. And so you would just throw that out and not use it. So generally you go with the highest and the lowest, but not always. So we'll say that what Garcia is going to do is pick April for his high point and February for his low point. And if you look at page 268, right in the middle of the page is a little data table there that shows the operating hours and maintenance costs for January through July. And so he went with February as his low point because that was the fewest hours, 3,325. And he went with April as the high point because that was the most hours, which is 3,614. That wasn't the highest or lowest cost. He went with highest or lowest hours because to him that was the driver that was going to cause cost to happen. And so the next step is to calculate the equation of the line connecting the 2 points. Okay, so he went with April as a high of hours and February is a low. The difference between the high and the low for hours is 289. The difference between the high and the low for cost is $520. And so his variable cost then is 520 divided by 289 hours, which equals $1.80 per hour. So he's saying every hour would result in $1.80 of variable cost. Okay, and so fixed cost equals total cost minus the estimated variable cost. Obviously, that's an estimate of variable cost. So total fixed cost then is 23,030, and that's his April number. That 23,030 is his April high number, minus 6,505, which is $1.80 times the April hours, 3,614. Okay, that gives him 6,505, which equals 16,525 for fixed. So now we go back to our formula, that formula we looked at the top of page 269, and we're saying that y equals, which is total cost, 16,525, which is A, the fixed cost, plus $1.80 times x. Okay, $1.80 being the variable cost per hour. Okay, and we can continue to solve for that here, and basically saying now what we're going to do is guess or kind of assume what we expect operating hours for August to be. Obviously we're kind of guessing, we don't know for sure, but if we're trying to predict August cost, now we have to be able to predict operating hours for August because that's going to be a key driver to operating cost. And so we use our 16,525 plus $1.80 times x, where x is the estimated operating hours for August. Okay, so 16,525 plus $1.80 times 3,600, and we get $23,005 in maintenance costs. So using the high-low method, we are predicting $23,005 of maintenance cost for August based on the information that we saw from January through July. So the pros of that, that was not a difficult calculation, did not require a lot of effort, just gathering some data and comparing it for 7 months in this example. Provides a unique cost equation that can be used to predict future cost, okay, the equation that we looked at. The cons relied on only 2 data points, the highest and the lowest, and those data points required some judgment because we discard most of the data, right? We just, out of 14 pieces of information, a cost and an hours for 7 months, we threw out all but 4. Okay, so we didn't use all the data. Regression analysis based on statistics is more accurate, okay, which of course is also much more time consuming than the high-low method. So high-low methods are focused for chapter 8. That's all we're going to cover. And just be aware of what a regression is we're using statistics then to estimate future cost using all the data points to predict some future thing, some future cost or some future event based on previous costs. Okay, so that's what a regression is going to be.